Assalamu alaikum wa rahmatullahi wa barakatuh. Hello, my name is Sofwan. Welcome to ENT 336 Fluid Machinery online class. Today, I will talk about the velocity triangles and efficiency of steam turbine. This is an impulse turbine stage consists of the nozzle and rotor. Steam enters the nozzle at the inlet with velocity v1 and leaves the nozzle with absolute velocity v2. We can see here that the velocity v2 is increased in several order compared to v1 by the nozzle. The steam then enters the rotor and glide through the rotor and then exit the rotor with absolute velocity of v3. Now we focus only on the rotor or the blade. Steam with velocity v will enter a stationary blade at a certain angle. The blade is also moving in the direction represented by the blue arrow with velocity u. Because of that, if the steam nozzle is set at angle beta, steam will not enter the blade at the desired angle. Therefore, steam must be directed to the blade at angle alpha so that it will enter the moving blade at angle beta. At the rotor entrance, this angle is known as nozzle angle and blade inlet angle. The absolute velocity of the steam is represented by the red dash arrow, and the green dash arrow represents the steam relative velocity to the blade velocity. Here, looking at this velocity triangle, we can say that vector v2 is equal vector u plus vector vr2. Vector v2 or the value of velocity v2 can be set or measured. However, velocity vr2 need to be determined or calculated. So this is a better representation of the equation. So this is about the inlet of the rotor, where the steam enter the blade and glide to the exit of the blade. Steam leaves the blade with velocity Vr3 at angle beta 3. Velocity Vr3 is relative to the blade velocity. And the blade is still moving with velocity u. And this is the absolute steam velocity leaving the blade at angle alpha 3, represented by the red arrow. We can combine the velocity triangles at the inlet and outlet of the blade in order to make analysis easier. We can see here u is exactly the same. That is why we don't have u2 or u3. We simply denote it as u. Certain components of this velocity are producing output. The momentum at the inlet minus the momentum at the outlet of the blade will produce the net force to the blade. In order to calculate the net force, first we have to get the component of V2 and V3 in the direction of u. Using the angle alpha 2 and alpha 3, we can get those components. If we multiply this with the mass flow rate, we will get the net force exerted on the blade, which causing the blade to move. This is the whirl velocity VU2, and this is the whirl velocity VU3. If you look in the velocity triangle, VU3 is actually in the negative direction. So we can rewrite this equation to be like this. Next, if we multiply the force with blade velocity, we will get the power exerted on the blade, or the power produced by the blade, which usually written in terms of kilowatts. So we have to divide it by 1000. Now we want to know what is the efficiency of this diagram, or the efficiency of the blade or the rotor. The blade is supplied with energy of half mv squared from the incoming steam flow. The blades are not able to convert all of the incoming energy because some of them will go with the output velocity. So in order to get the efficiency of the blade in converting the kinetic energy into power, we can use this rotor efficiency equation, which is the ratio of the power produced over the kinetic energy supplied by the steam. Inserting the equation for power, we get this equation, and we can cancel the mass flow rate into the final form of rotor efficiency of 2VU2 divided by V2 squared. If we look into the final form of rotor efficiency, this part is actually the specific work done by the rotor. Finally, we want to look into the gross efficiency, or the total to static efficiency. This efficiency is given by the efficiency of the rotor multiplied by the efficiency of the nozzle. The efficiency of the nozzle can be calculated by the ratio of V2 squared over V2S squared. The ratio of V2 over V2S is actually the velocity coefficient in the nozzle. So now we have talked about the steam turbine velocity triangle and some of the turbine efficiency for steam turbine. Thank you. See you again in our next video.